In this section, we're going to learn two different tests to determine where our local maxes and local mins are. And in this video, we're going to cover the first one, which is the first derivative test. So I want to take a moment to analyze this graph, and in particular, I want to look at the behavior of the graphs near and at the local maxes and the local mins. So we're going to start at A, and I want you to look on the left side of A and see what the graph is doing on the left side of A. And so if we look at the graph, we notice that on the left side of A, and again, we read the graphs going left to right, that the graph is going uphill, or in other words, increasing. And if you remember from section 3.2, if the graph is increasing, we know that the first derivative is greater than 0, right? It's positive, meaning the slope of the tangent line is positive all along here, isn't it? So it's increasing. So f prime is greater than 0. Another way we can say that is f prime of x is positive. On the right side of A, we see that the graph is decreasing. It's going downhill. So that means f prime is less than 0, or f prime of x is negative. All right. We have a similar situation over at D. The difference between A and D, hopefully you can see that the difference is that at D, we're increasing on this side. Our tangent line has a positive slope. On the right side, the tangent line has a negative slope. And then at the top, at the very top, we have our tangent line having a slope of 0. So in this case, f prime of D is 0. The difference at A is that it's positive on the left side. F prime is positive, and then f prime is negative on the right side, but we never hit a slope of 0. Instead, this tangent line becomes infinitely positive. It becomes vertical, and vertical lines have an undefined slope. So in this case, f prime is undefined at A. And so that's the difference between A and D. Now let's look at B. If we look at B, we have a negative slope or decreasing function on the left side of B. So that means f prime is going to be less than 0, or f prime of x is going to be negative. And then on the right side, it's increasing. And so f prime is greater than 0, or f prime of x is positive. All right, so let's look at C. That's our final point. And C is neither a max nor a min. And you can see that even though f prime of C is equal to 0, the graph does not change slopes on either side of C. So it's increasing over here, so that means f prime is greater than 0. And then on the right side, it maintains that positive slope, so f prime is still greater than 0. So in this case, even though we had f prime of C is equal to 0 at C, or f prime of C is equal to 0, it did not change signs. F prime did not change signs at C, and so we have neither a max nor a min. So we can summarize what we just learned with the first derivative test, but before we do that, I want to remind you that if a continuous function f has a local extremum, so if it has a local max or a local min, it must occur at a critical point. However, just because you have a critical point, it doesn't guarantee a local max or a local min. And C was an example of that in that graph I just showed you. All right, so let's move on to the first derivative test. And I want you to read this for a moment and see if you can't figure out what it says. The test says, suppose that f is a continuous function over an interval I containing a critical point C. So we have some function and it's continuous over an interval that we're given, and we have a critical point C. There may be other critical points along there as well, but they're giving an example. There is at least one critical point C. It says if f is differentiable over that I, meaning the derivative exists over that entire interval, except possibly at the point C, because remember, critical points can occur where f prime of C is undefined, then f of C satisfies one of the following descriptions. So if f prime changes sign from positive to negative at x equals C, then f of C is going to be a local max. If f prime changes from negative to positive at x equals C, then f of C is going to be a local min. And finally, if f prime has the same sign on both sides of C, then we have neither a local max nor a local min. And I'm going to show you an example of how we apply this test to an actual function. So here's our example. We have f of x is equal to negative x cubed plus 3/2 x squared plus 18x. And the first derivative test tells us that we need to, first of all, determine the critical points. And to determine the critical points, recall that we need to take the derivative and find out the places where the derivative is equal to 0 and where it's undefined. So I'm going to take the derivative and I get negative 3x squared plus 3/2 times 2x plus 18. And I'm going to simplify that and I get negative 3x squared plus 3x plus 18. And so there are no places where the first derivative is undefined, but I am going to set this equal to 0 to find out the x values where the first derivative is 0. And remember what we're finding here. These are the places where we have a horizontal tangent line, and so those are potential maxes or mins. So I'm going to factor out a negative 3, and I'm going to end up with x squared minus x minus 6 equals 0. And I can check myself by multiplying that back out if I need to. And now I'm going to factor it, and I get x minus 3 times x plus 2. I believe that is what we end up with. Again, multiply it back out and see if you get what you started with, if you need to. So now I'm going to, we know if we have a product of things that equals 0, that means one or more of them have to equal 0. So that means x minus 3 has to equal 0, or x plus 2 has to equal 0. So that means x equals 3, or x equals negative 2. And remember what those are. Those are our critical points, all right? So what I like to do at this point is I like to put them on a number line. And I put them in order. So negative 2 occurs before 3, so I put it like this. And now what I'm going to do, remember we said if it switches sign at those critical points, then we're going to have an extremum. All right? And so what I do is I pick a number on the left side of negative 2. All right? And remember what we're trying to find. We're trying to find if it's increasing or decreasing at that point. So to find out if it's increasing or decreasing, you plug it into the first derivative, right? So I'm going to pick negative 3. And so I'm going to find f prime of negative 3. What that gives me is negative 3 times negative 3 squared plus 3 times negative 3 plus 18. And really what we're concerned about, we're not concerned about the number. We're concerned about whether it's positive or negative. So we're going to get negative 3 times positive 9 is going to give me negative 27. And then negative 9 plus 18. And so I can see that the negatives outweigh the positives. So all we're concerned about is that we have a negative value here. And negative means that it's decreasing. And so what I like to do is I like to draw a line like this to signify that it's decreasing. That's not a very neat line, but it's decreasing. Now I'm going to take a number over the interval from negative 2 to 3. And so let's pick 0 because 0 is super easy to work with. So I'm going to pick 0, and again, I'm going to plug it into the first derivative. And if I do that, I get negative 3 times 0 plus 3 times 0 plus 18. And so that is going to give me a positive value. So I go up here and I put a positive, and remember positive means increasing, doesn't it? So I can see here that it was decreasing on the left of 2, increasing on the right of 2, and I draw myself a little thing like this, and you can see that that is a min, isn't it? Now I'm going to check on the other side of 3. I'm going to check any number would work. We could use 150 if we wanted, but I'm just going to pick 4 because any number on the right side of 3 works. And if I plug 4 in there, I'm going to get negative 3 times 4 squared plus 3 times 4 plus 18. And this is going to give me negative 3 times 16 plus 12 plus 18. And so 12 plus 18 is 30. Am I going to get a bigger or a larger negative number? I sure am. So we know that this whole value is going to be negative. Again, we're not concerned about what the actual value is. We're concerned about whether it's positive or negative. So since this number is a larger negative than the two of these added together, we know that we're going to have a negative value. So that means that the graph is decreasing after 3, isn't it? And so that means at 3 we had a local max. And so the way we answer this question is that the local min occurs at x equals negative 2. And then we can find the value of the local min by plugging negative 2 into the original equation. All right, so we'd find f of 2, and that would be equal to negative 2 cubed plus 3 halves times negative 2 squared plus 18 times negative 2. And if you calculate that out, you'll get negative 22. And so we know that there is a local min that occurs at x equals negative 2, and the value of that is negative 22. And that corresponds then to this point on the graph, negative 2, negative 22, right? This is where the local min is. We also know that there's a local max at x equals 3. So we could find that local max by plugging 3. And again, we're plugging it into the original equation because we're trying to find the y value. If we plug it into the derivative, that's telling us whether it's increasing or decreasing. If we plug it into the original function, that's telling us the actual y value. So we have 3 cubed plus 3 halves times 3 squared plus 18 times 3. And if you make that calculation, it is 40.5. So again, we have a local max at x equals 3, and its value is 40.5, and it corresponds then to the point 340.5. You would see this point on your graph. Now, one of the questions I used to ask myself is, how do we know that there are no other points where it changes from increasing to decreasing or decreasing to increasing? And we are guaranteed that there are no other points because we found the only places where the derivative was equal to 0 by setting the equation equal to 0. And we found out that that happened at x equals 3 and x equals negative 2.